Hello everyone, my name is Praful and I am the leader of Group B CSCI992 subject. Our group has designed and developed a project called Face-Based Retrieval of Images, which I will be giving you an introduction about today. Let me first briefly give you an idea about the project. The main objective of the project is to demonstrate the use of content-based retrieval of images, along with our traditional text-based retrieval of images. In a traditional text-based search, we simply type in something that we want to search. In content-based search, we use the content such as image of the topic that we want to search. Content-based search can be done using images, but is not only limited to that. But a project makes use only of images, so that is all we are going to be talking about. In our project, we used a dataset provided by the National Archive of Australia, which included the images of famous Australian personalities. We call the dataset NAA345K, as it constitutes of 345,000 images. Along with the images, the text annotation related to each image was provided, which we used to extract information such as the name of the person in each image. As mentioned earlier, the main objective of the project is to demonstrate the use of content-based search. So in this project, along with the traditional text-based search, we allow the user to upload an image, and the system detects and identifies the faces in the image and retrieves the faces of all the people in the dataset, if available. Let's have a look at the technologies used in our project. Python is a very popular programming language for machine learning tasks. So we decided to use a Python framework called PyTorch to achieve face detection and face recognition. For face detection, we used a pre-trained machine learning model called MTCNN, which would detect faces in the images and give coordinates of the box around the face. We used another pre-trained model called Inception ResNet for feature extraction. The model returned a 512 dimensional vector which represented a face in a 512 dimension. The information was then used to cluster the faces using the k-means algorithm from scikit-learn library into groups where each cluster would represent a person ideally. We performed natural language processing on the text annotation provided within the dataset. In order to do that, we made use of the libraries called NLTK and Core NLP. From that, we used the named entity recognition tagger to identify the names in the text, which we later used to label the clusters. Throughout this process, we used MongoDB to store all the information in collections as documents. As initially we did not have a structured data, we decided to use MongoDB as it is popular for storing JSON documents. We developed a progressive web application using a very popular JavaScript framework called React.js. A progressive web application is an application that works on any platform that uses a standard compliant browser. For the backend, we used a Python library called Flask, which is a micro-web framework written in Python. It acts as a middle layer between the front end and the database and connects them both using RESTful APIs. We used Mongo as initially we did not have any structured data to deal with. Later, we managed to structure the data, so we migrated the database to MySQL, which is an open source relational database. Now let's have a look at the project. The first page of the project is the overview page. Here the user can get introduced to the project, what the project is all about, and what features are available for the user to access. On the left you can see how the project will appear in mobile view, and on the right you can see how it looks in the desktop browser. The second page is the search by text page, where the user can input the name of the person in the text field. The text field is an autocomplete text field, so it will give suggestions to the user with the name of the people available in the database. Using that name, the user can click on search and get a list of all the images of that person in the database. The next page is the search by letter page. Here the user can select the alphabet and a list of all people whose name starts with that alphabet will be listed. From that list, the user can select the person whose images they want to search and can click on that name. The system will generate the pictures of that selected person. The content-based retrieval of images is displayed on this page, Search by Image. Here the system will allow the user to upload an image. The system will then use the machine learning techniques mentioned earlier and will detect if there are any faces available in the picture. If yes, then the system will look for the person in the database, and if found, the pictures of that person will be shown. Else no results will be displayed. This is the true demonstration of content-based retrieval of images. Lastly, we have the search by name page, where the names of all the people whose pictures are available in the database will be displayed. The user can select the name of any person and the pictures of that person will be shown. Not only can the user see the images of that person, but when the user clicks on any image, the user can see all the analytics related to that person and all the information about the image, such as who all are present in the picture, when was the picture taken, etc. That is pretty much what the project is all about. Please feel free to ask any questions. Thank you.